In this video, we're going to go over a slightly more complicated torque problem. This will be an important stepping stone as we develop our expertise in torque and starting to solve progressively more and more complex problems. In the first 2 minutes, I will revise and review the method that we had for approaching any torque related problem. So this will be really useful for people that don't know how to approach these problems and don't know where to start, right? I will explain basically a roadmap for approaching these problems. And then we'll apply those steps to solving our practice problem for today. So let's firstly start by examining our method. So our method is essentially the same as it was for approaching problems that had to do with forces, right? We always start by drawing a free body diagram. We ask ourselves what forces are present and where are those forces pointed, left, right, up, down, or at an angle. We choose a coordinate system, right? So typically when we talk about torque, clockwise is a negative direction and counterclockwise is positive. Then we need to identify the rotational point. So this step we're going to especially practice in this following problem that's going to come up, because this step right here is very subtle but also very important, because if the object is now rotating, you can kind of pick whatever rotational point you want, and we'll discuss how do you know what to pick as your rotational point, as your point of reference. Then you'll know the distances of each force from that point you just picked. Now in most problems you'll write down basically sum up all your horizontal forces, all your vertical forces, right? And either set them equal to 0 or MA. Finally, you will also set up net torque is equal to I times alpha. So you'll add up all your torques over here and set them also equal to moment of inertia times alpha. Then you'll have three equations, right? One for the Newton's second law in the x direction, one for the second one for the Newton's law in the y direction, and third one for the rotation. And this system of three equations can solve essentially any problem that we're going to approach in this unit. So that's our method, to set up those three equations, and all your answers will flow from there. Let's see how this method, right, applies to this next practice problem right here. Here we also have a uniform horizontal beam that is 20 meters long with a mass of 40 kilograms. So let me draw here a beam. So the beam is supported by two supports. Each one is located 5 meters away from the beam's end. Okay, so this distance right here is 5 meters. Allowing the beam to remain horizontal without tilting or rotating. So essentially we have no rotation and no, of course, no acceleration, right? Because the beam is not moving. On this beam, there is a person standing at a distance of 7 meters from the left end. Okay, so we have a person now. Oof. Oh, and by the way, right, we know that the total distance here of 20 meters of the beam. So, okay, the mass of this person is 70 kilograms. Your task is to find the normal forces exerted by two supports. Great. So, firstly, as always, let's firstly draw the free body diagram on the beam. As always, you draw the free body diagram on the thing that should be rotating, which is the beam in this case. Firstly, the beam will experience its own mass, right, of mg. Let's call this m1 and this one m2, the mass of the person. Then there will of course be the gravity from the person itself, so m2g. Then there's going to be the two supports that are holding it up. So normal force M1 and normal force N2. Fantastic. Okay, so we don't have, right, there's only vertical forces here, so only y direction. So let's write down our second Newton's law in the y direction. F net is equal to MA. The normal forces up, right, are N1 and N2. Forces down are M2G and M1G. And of course, this object is now rotating, so it's equal to 0. So you know M1 and M2, but you don't know both of these, N1 and N2. And this is why we have to use the torque, right? This is why we have to also write another equation, because we have two unknowns here, right? So how are we going to solve this? Well, don't worry, because we have torque. So T net, the net torque is equal to 0, right? Now, here we'll have to pick the rotational point, and this is going to be like really the juice of the problem, right? The really important step of the problem. So the thing is, we can have the freedom to pick any point as the point of rotation, because we know this thing is now rotating, so we can pick any point as a reference point. It makes sense to pick a reference point either from N1 or N2. And the reason for that is because you don't know, you want to cancel out one of these forces, right? So for example, I can pick my left point as the point of rotation. So this point right here. Then let's calculate the distances, right, of each force from that point. So as makes sense, right, N1 has the distance of 0, which is why I picked that as a point of rotation, because now I can cancel out N1. M2G will have the let me take a look. So let's think, what is the distance away from that point? So we know it's 7 meters away, and this one here is 5 meters, right? So therefore that distance here that's left is 2 meters away. So M2G will have a distance of 2 meters. What about M1G? Oh, and let's think about the sign, right? So this force would make it rotate in a clockwise direction, so it's negative. So it's negative M1G. Same thing for M1G. Right, it would make it rotate in the clockwise direction, so therefore it's negative. Okay, what about the force, this distance right here? So it's, remember, this force is the force of gravity from the beam, so it's applied at the center. So this total distance right here is 10 meters. This distance right here is 5 meters. So the distance that we have left here is 10 minus 5, or 5 meters. Finally, what about this force N2? So we have essentially 5 meters here and 5 meters here, and we're trying to find this total distance right here. If the total length of the beam is 20 meters, and we cut off 5 and 5 from the end, you can see that in the middle, this distance is going to be 10 meters, right, that of N2. So N2 is the distance of 10 meters away. This is really going to be, right here that we just went through, was the most complex part of this problem, is just to figure out the distances and our point of rotation. And that's what I wanted to also demonstrate with this problem. So now let's just write our torque. We're almost done, guys. So N1 times 0. So torque is force times distance, right? So N1 times 0 minus M2G times 2 minus M1G times 5 plus N2 times 10 is equal to 0. Now, of course, N1 times 0 is going to cancel out. So we essentially rearrange our equation for N2. So N2 times 10. I'm going to put these terms on the right hand side. So M2G plus 5 M1G, and I'm going to divide both sides by 10. So plugging in all the terms, it's 2 times the second mass, right, is 70 kilograms times 9.8 plus 5 times 40 kilograms times 9.8 over 10, and 2 is equal to 333.2 newtons. So that's the normal force from the right support, and then the normal force from the left support you can find from the second Newton's law that we drew, right? Because it's going to be a lot simpler than trying to set up another torque equation, right? So it's a lot simpler to find already from N1, from this equation. So M2G plus M1G minus N2. And then if you plug in all the numbers, you'll find that N1 is equal to 744.8 newtons. So just like this, we found our left, our normal force from the left and the right support. So what we learned here, right, is how to set up and how to take advantage of the fact that we can pick any point of rotation if the object is now rotating and calculate the distance away from it. Now that we solved this really important problem, in the next problem, I'm going to go over some even more complex examples of torque, especially when forces are now at some sort of applied at some sort of angles. So the next problem will be a pulley related problem, a very typical problem for torque. So if you haven't solved this before, I would highly advise you watch that video after. Thank you guys for watching. As always, keep practicing and keep watching these videos on your way to an A. Thank you for watching.